this is a pre-built version of the application. So first we will do a quick high-level overview of the code. So this class creates and populates dataset tables. So it has to do with data coming from the database. And this class creates and populates hard-coded two-dimensional arrays datasets. So it has to do with hard-coded data. And for data coming from files, it's coming from .csv files. And this is an example. And this class prompts the user for the .csv file, table, or hard-coded data source name. And it obtains and returns data as a two-dimensional array from .csv file, from table, or from hard-coded data source. So here we are getting the data from a SQLite database. So the database name is data.db, and the directory name where we have those files is data. And this class prompts the user for data source type. Is it hard-coded, or from the database, or from .csv file? And we prompt the user for the desired probability calculation. And the possible calculations is this for a probability, and this one for conditional probability, and this one if we have OR. So feature 1 equal value 1, or feature 2 equal value 2. And displays data source contents as a table, and the sample space omega is the set of all possible outcomes of an experiment. So example, so we are dealing with all those tuples, so omega is true everywhere. This is the sample space. And an event represents a subset of the sample space omega, and the intersection method returns a new event containing a set of common items in this event and the passed-in event. This class represents an item in the sample space omega. So here we have a map of features and their associated values. And this class contains probability and conditional probability calculations functionality. And we have those two libraries that we are using. So the commons math library, since we are doing fractions here. And this one, since we are using an SQLite database. Next, let's do a quick demo. And in order to start fresh, let's delete the database. And here this class creates and populates the database. So currently we have the weather, the shapes, and the words tables that we are creating and populating, and we can add additional methods for additional tables. So let's go ahead and run it and do a refresh. So this is the new database that we just created. Next, let's go ahead and run the application. So let's start with hard-coded data and maybe pick shapes. And let's do database and maybe pick words. And file, and maybe pick weather CSV file. So we can switch between various data source types, either hard-coded or database or file. And let's do another run. And let's go for data coming from file, maybe this file. And let's calculate the probability that omega is always true. So it's 1. And the probability that language is Italian, given that word is tigre. So we have 3 tuples. So the word is tigre is the same in 3 languages. So we end up with 1 out of 3. So we can calculate it this way. Probability of language is Italian and the word is tigre is 1 out of 11 tuples. So here we have 11 tuples and 1 out of 11. And the probability that word is tigre is 3 out of 11. So we end up with 1/3. And the probability that language is French is 2 out of 11. So we have this one and this one. So this is marginal probability. So it is the same as this. So word can be anything and topic can be anything. So marginal probability is when only a subset of the variables is specified, and a joint probability is where all the variables are specified. So the probability that language is Spanish, given that language is Spanish. So it is 1. So we calculate this over this. And we have 3 tuples where 5 tuples where language is Spanish. And let's calculate this. The probability of the sample space omega being true given that language is Spanish. it is 1. So omega is always true. And let's calculate this. So probability that the word is elephant, or the topic is colors. So we have those 6. So the probability that word is elephant is 2 out of 11. And the probability that topic is colors is 4 out of 11. And we subtract the probability that word is elephant and topic is colors. So those are 2 disjoint events. This one and this one. So we're subtracting 0. We end up with 6 out of 11. So a sample space omega is the set of all possible outcomes of an experiment, and an event E is a subset of the sample space, and we have 3 probability axioms. The probability of an event E is between 0 and 1, and the probability of the sample space omega is equal to 1, and the probability of event E1 union event E2, etc., is equal to the probability of event E1 plus the probability of event E2 plus, etc., where E1, E2 is a sequence of disjoint events. If those events are non-disjoint, so if we have 2 events, then we have to subtract their intersections, since we would be adding them 2 times. So we subtract one of those times. And a sample space consists of n equally likely single element events, and the probability of any event A is given by the probability of A is equal to the number of elements of A over n, and the definition of conditional probability is equal to the probability of the intersection of A and B, of events A and B, over the probability of events B. So probability of A given B. After downloading, and let's do a quick test run. Now a members only version is available for viewing by channel members at the software engineer level and above, and it includes step-by-step coding, and the source code is available for download.